Hello everyone, welcome all. So today we are going to overlook some basic terminology related to thermodynamics. Okay, it's a very vast subject, so we will get on with the topic. Okay, so what do you mean by equilibrium? Equilibrium means what? A body is said to be equilibrium when it attains thermal, chemical, thermal, chemical, and mechanical equilibrium with the surrounding. Okay, means what? A body is said, if the body is said to be in equilibrium, means what? It has achieved thermal equilibrium, chemical equilibrium, and mechanical equilibrium with its surrounding. So we'll see one by one what exactly thermal, chemical, and mechanical equilibrium means. Okay. For example, if a body is in thermal equilibrium, means what? If says this is a body, this is a body A. Okay, if this body is in thermal equilibrium with its surrounding, means what? There is no temperature gradient. There is no temperature gradient inside the body. If there is no temperature gradient, means what? The temperature of the body A and the temperature of the surrounding. If this is the surrounding, if this is the surrounding, okay, so if the temperature of the body A and if the temperature of the surrounding is one at the same, then we can say that the body is in thermal equilibrium. Understand this term. Okay, means what? Here delta T is equal to 0. Means what? There is no temperature gradient. The temperature, say if the temperature of this body is 25 degrees Celsius and the temperature of the surrounding or the weather is 25 degrees Celsius, then we can say that the body is in thermal equilibrium. Are you getting it? Okay, so now going towards the chemical equilibrium. Okay, so what do you mean by chemical equilibrium? chemical Chemical equilibrium. Okay, so the body is said to be in chemical equilibrium where only and only when there are no chemical reactions going on inside the body. There is no chemical reaction. Okay, if there is no chemical reaction going on within the body, then we can say that the body is said to be in chemical equilibrium with the surrounding. For example, to understand this in more simpler terms, there are no molecular forces active inside the body. Understand this. Okay, there are no molecular forces. There are no chemical reactions going on within the body with the surrounding. Okay, and there are no molecular forces which are urging the body to undergo chemical reaction. Okay, means what you can say that the body is also chemically stable. Are you following it? The very best example is of sodium metal. When it's exposed to atmosphere, it burns very quickly. Why? Because it is not in chemical equilibrium. Are you following it? Okay, so this state is known as chemical equilibrium. Okay, now going on to the third state, that is mechanical equilibrium. Mechanical equilibrium. So when can you say the body is in mechanical equilibrium? When there are no unbalanced forces. When there are no unbalanced forces applied on the body. When there are no unbalanced forces. Okay, getting it? When there are no unbalanced forces inside the body, the summation of f of x, summation of f of y, and summation of moments inside the body is always equal to 0. Means what? The body is perfectly static. Are you following it? The body is perfectly static with the surrounding. There are no unbalanced forces acting on the body. No forces in x direction, no forces in y direction, no forces in z direction, no force, and there is also no moment applied on the body. Okay, the moment applied to the body is also equal to 0. Means what? The body is perfectly stable and it's completely static. Okay, so when the body is thermally, mechanically, and chemically equilibrium with the surrounding, hence we can call it as the body has attained its equilibrium state. Are you following it? Okay, so this is known as equilibrium. This is known as equilibrium attained by the body. So the next term that we are going to see is known as system. What do you mean by system? Okay, system. It's very important topic known as system. Okay, so a system is nothing but a particular region in space. I repeat again. A system is nothing but a particular region in a space. For example, this is a space. This is a space. Okay. So if I occupy a particular region, say I occupy this region, I can call this as a system. So understand, a system has a particular function to perform. Okay, a system has a particular function to perform. So this is system, and this space I'll call it as surrounding. What I call it as? I'll call it as surrounding. And together, system and surrounding together will make universe. What will make? Universe. So universe consists of system and surrounding. Are you following it? Okay, so this is a very basic way to introduce what is system. System is nothing but a particular region or a quantity of matter. Okay, quantity of matter in a space or a particular region of a space is known as a system. Okay, so to go into detail, to go into depth, what you will see, if there is a system, there is a system. Okay, this is the arbitrary system and this is a surrounding. Okay, this system and this is a surrounding. So there is a certain line, which separates system and surrounding. So this line is known as a boundary. This line known as a boundary. Okay, are you following? This line is known as a boundary. Okay, so if this line which is separating system and surrounding, if it has a physical surface, imagine if it has a physical surface, then it is known as a real boundary. Okay, if this surface, if it has a physical surface, if this line has a physical surface, then we call it as a real boundary. If it has an imaginary surface, or it doesn't have any physical surface, then we call it as an imaginary surface, imaginary boundary. Okay, so from this what you can understand, that boundaries are of two types. One is real boundary and one is imaginary boundary. Okay, and mathematically boundary has no weight, means mass is negligible. Understand, this is very basic, very important when you consider to solve numericals related to system and surrounding. Okay, understood? So boundary is nothing but the space which envelops the system. Okay, or the space or the line which separates the system and surrounding. Okay, getting it? It can be real. If it has physical surface, it is real boundary. If it has imaginary no physical surface, it is not imaginary boundary. Are you following it? Okay, so now there are three types of systems. Okay, there are three types of system. So what I told you, every system has its own, every system has its own function to perform. Okay, system means what? It has some function to perform. For example, in our body, we have numerous amount of systems: digestive system, respiratory system, urinary system, excretory system. So what do you mean by system? System has some particular aim to do, a particular work to perform. Okay, are you following it? So the first type of system is known as closed system. What do you know? What? Closed system. Okay, it's known as closed system, or also known as controlled mass system. Controlled mass system. Why it is called controlled mass? You will come to know later. Just hold on. Okay, controlled mass system, or also known as fixed mass system. Fixed mass system. So first it is called as closed system, or else it is also called as control mass system, or else it is also called as fixed mass system. Why is called so? Why there are so multiple names? I will come to know. Don't worry. Okay. So what exactly is closed system? Okay. Understand, a system always carries some energy and mass. Energy and mass. Okay, so what is energy and mass? These are two fundamental quantities, as you know, MLT. These are two fundamental quantities, energy and mass. A system always carries energy and mass. Okay, so in a closed system, there is interaction. There is always, to perform a function, there is always interaction of energy and mass. Energy and mass should cross the boundary. Energy and mass, both of them should cross boundaries, so should have some interaction with the surrounding. Then the function of any system can be satisfied. Okay, so how it is operational, I'll tell you. Okay, for example, imagine this is a system. This is a closed system. This is a closed system. Okay, closed system. Okay, this is a closed system. This is the surrounding. I'll explain with the example, don't worry. Okay, this is a closed system. Okay, so what in a closed system there is always energy interaction. There is always energy interaction with the surrounding. Means what? Energy can cross the boundary. See, I already explained you what is the boundary. This is the imaginary line, imaginary or real line, you may assume. If energy crosses this boundary, if the energy crosses this boundary, then it is known as closed system. In closed system, mass never crosses this boundary. Understand this. So in closed system, mass never crosses the boundary, but energy can either cross the either interact with the surrounding, or either it will come or it will go away. Okay, but mass will never cross the boundary. Understand? Mass will be always contained within the system. Mass will never cross the boundary. Are you getting it? But here energy can either go from system to surrounding or come from surrounding to system. Okay, there are sign conventions, but that will deal later. Okay, so here energy crosses the boundaries. Means what? Energy either can go out of the system or either come into the system, but mass never interacts with the surrounding. Mass is always enclosed in the system. So as I told you, closed system is also called as fixed mass system, control mass system. Why it is called? Are you getting the concept now? Why? Because mass never crosses the boundary. Mass is always contained within the system. Okay, so how can you define a closed system? A closed system is that system where only energy interacts with the surrounding. Are you following it? Mass never interacts with the surrounding. Mass is always enclosed in the system. That's why we call it as fixed mass system. Are you following? What is the best example? The best example here. So to to explain it with the best example, I will give you the very best example of a cell phone. With a cell phone. Okay, so this is the cell phone. This is a cell phone. Okay, so today, okay, so this is a cell phone, one button here. So if the cell phone interacts with the energy, what kind of it interacts with the radio waves. Okay, but the mass of the cell phone never dies away. For example, if your cell phone is 50 grams, okay, so you have called your friends, you have talked 10 minutes, so does the weight differs? No, the weight is one at the same. Okay, getting it? So this is the best example of a closed system. So here there is energy interaction, the mass always remains the same. So cell phone is the very best example. Another best example is moon and earth. Now you will say, what is this example, moon and earth? See guys, this is earth and this is the moon. So moon and earth mutually what they try to do, they try to exert which kind of force? Gravitational force. Okay, gravitational force onto each other. This is also best example of closed system. So moon and earth both of them are part of a system. Getting it? So if the moon, see, if this is the moon and this is the earth, okay, if moon exerts some force onto the earth, what is the effect? Waves are produced. Okay, but what does it do? Does it consumes the whole moon? No, the mass of the moon is constant, the mass of the earth is constant, but still there is energy interaction between both of them. Are you following it? Are you getting the concept now, guys? Okay, so another example to give is, say, refrigerator. So what is refrigerator? What does the refrigerator do? So if I if I put an apple of, say, how much, 25 degrees Celsius. Okay, so what it will try to extract the heat out of it. Okay, what is the function of refrigerator? To extract the heat from the elements. Okay, so it will extract the heat. Okay, and it will make its temperature around 2 degrees Celsius. Okay, but if when I'll pull out this apple, which is at 2 degrees Celsius, its mass always will remain constant. Are you following it? The mass of the refrigerator will also remain constant. Why? Because it's a part of a closed system. Are you following it? So there is interaction of energy. See, here is interaction. The heat energy is being interacted, but the mass is remaining constant. Okay. So there are much more examples. See, there is a power plant, thermoelectric power plant. Okay. The very best example for you guys is, say, bat. This is a bat. Okay, cricket bat. So if you middle, you see, here is a sweet spot. Those who are playing cricket might know here it is a sweet spot. For example, if you hit the ball, so what will happen? You transfer the energy from the bat to the energy. The ball will travel like this towards the boundary. The ball is traveling. The ball is carrying some energy. From where did it got its energy? It got the energy from the bat. So you have transfer energy, but you have not transferred the mass of the bat. The mass of the bat will always remain constant. Okay, means what? Here also there is only transfer of what? There is transfer of energy. There is no transfer of mass. So this is the example of closed system. So I hope you understood what is the closed system. So another type of system is known as open system. Open system. Okay, also called as control volume system. Control volume system, or it is also called as fixed volume system. Fixed volume system. Understand? We'll recall about the closed system. Closed system is also called as control mass and control. Control mass and fixed mass system. Okay. So why it is called as, I have told you, because the mass is always contained within the system. Okay. So here see the names are changed. Open system is also called as control volume and fixed volume. Okay. So what we will try to do, we will try to understand what is open system. Okay. So if it is an open system, if this system is an open system, what will happen? See, this is a system. This is a system which is called as open system. In open system, mass and energy, both of them interact with the surrounding. Both of them will interact with the surrounding. Understand this. Both of them will what they will do? Both of them will interact with the surrounding. Means what? Mass will either come out of system and add into the system, add into the boundary. Will cross the boundary. Okay. Energy can also be added or also be removed from the system. Okay. Getting it? So this is called as open system. Understand the basic difference. Here mass and energy, both of them can either cross the boundaries of the system. But in closed system, only energy was allowed, where mass was always contained. But here mass is not contained. Mass can also perform the same function as function of energy. Okay, getting it? So this diagram is becomes very important in order to understand what is open system. Okay, so what is the best example of open system? I will tell you what is the example of open system. First example that is very important is boiler. Boiler is very good example of open system. How? Will tell you just in a moment. For example, this is the boiler. What is the function of boiler? So the function of boiler is to supply steam. Okay, getting it? For example, here is the water. Here is the water level. If I provide heat, if I provide heat, say if I provide heat, okay, if I provide heat to the boiler, what is the outcome? That is steam. Means what? The mass and energy, steam means what? Heat energy. So heat energy and steam means what? Water. So water can also be extracted in the form of mass, that is m dot. Okay, means it can be written as kg per hour. Okay, getting it? Means the rate of steam which it can be extracted, which is kg per hour. Means what? Mass is also extracted and energy is also extracted. Okay, so boiler is the best example of open system, where the energy and mass, both of them can either cross the boundaries. Okay, another simpler example that can be discussed is fan. Okay, that is fan. Okay, now I will tell you how fan. Okay, imagine this is the fan. My drawing is not so. Okay, so for example, if this fan is rotating. Okay, you're getting it? So it's rotating. What it will try to do? It will try to pressurize the mass of air. It will try to pressurize the mass of air in this direction. Okay, means what's happening here? Mass is also transferring and energy is also transferring. Getting it? Are you following it? In this case, the amount of air around this fan is also transferring in certain direction, and energy of this fan is also transferring in a certain direction. Okay, getting it? So fan is also an example. Hydroelectric power plant, heat engines, IC engines are also examples of open system. Okay, are you getting it? So to sum up, what is an open system? Open system is that system which allows energy and it also allows mass to cross its boundaries. Are you following it? This is known as open system. Okay, so the third case very important also. The third case is known as isolated system or dead state system. Isolated system or dead state system. Are you following? Okay, So what do you mean by isolated or dead state system? For example, if this is a system, if this is a system, not only mass but and energy also cannot cross its boundaries. Means what? Energy and mass both are contained within the boundaries of a system. Mass and energy both cannot cross the boundaries of a system and go towards the surrounding. Are you following it? Okay, means what? The system is totally isolated from the surrounding. Are you following this? Are you following it? Okay, the system is the system is totally isolated from the surrounding. Means what? There is no interaction of mass and no interaction of energy. Okay, so what is the example? Every non-living things, every non-living thing in universe is comes under the category of a dead state. See, every non-living thing. For example, this pen. If I keep this pen like this, okay, there is no transfer. If I keep this pen idle, okay, so there will be no transfer of mass, no transfer of energy through it, okay, through the to the surroundings. So every non-living thing in the universe, okay, every non-living things in the universe always act at a dead state unless and until, understand this term, unless and until an external force is acted upon it. For example, if I keep this pen like this idle without acting upon an external force, so what will happen? It will act as a dead state. But if I give some moment to it, okay, it will roll along it, okay. So what will happen? If I apply external force, then it will interact energy, okay, then it will be no longer come under this category of dead state. So every non-living thing will be in a dead state or isolated system unless and until an external force is acted upon it. Are you following it? So this is known as dead state of a system. I hope you have understood these two basic concepts. Okay, thank you very much.